Okay, so now we're going to look at learning how to create tangent using the hand trick. So hopefully you've mastered sine and cosine so far. So tangent, what you're going to do is you're going to take your same left hand here and you're going to turn it down to the side. Now, the digits of your fingers are still going to be underneath a radical, and the digits are still the same. So we still have 0 degrees, 30, 45, 60, and 90. So everything remains the same. The only thing that's different is now we don't have a divided by 2. That's gone. We don't need that anymore. Okay? So let's take a look at it, all right? So the first thing we want to look at is 0 degrees, okay? So the tangent of 0 degrees is 0. So what happens here is, if I'm going to find out, well, what is the tangent of 0 degrees? Okay, you're going to say tangent of 0 degrees is equal to the square root of 0, because if you notice here, there are 0 digits up. So I'm going to say the square root of 0 divided by 1, 2, 3, 4. Okay, divided by square root of 4, which is 2. The square root of 0 is 0. Square root of 4 is 2. So the tangent of 0 degrees is 0 because we put our 0 degree finger down. Okay. Next thing we do is let's take a look at the tangent of 30 degrees. Now this one's a little tricky. You have to do a little bit of algebra, but still notice I put the 30 degree finger down. And now I'm going to say, well, what is the tangent of 30 degrees? Okay, so I've got the square root divided by a square root. Okay, notice that on the top of the fraction is a square root. So you got the square root of 1 divided by, on the bottom I've got 1, 2, 3, divided by the square root of 3. Okay, now this can simplify to 1 over radical 3, but remember, we do not want to have an irrational number in the denominator of our fraction. So what we're going to do here is rationalize the denominator by doing radical 3 over 3. So the tangent of 30 degrees is radical 3 over 3, and you can see it kind of matches up with what we have over here in our table. Okay, now looking at 45 degrees, the tangent of 45 degrees is 1. The slope of that arm there is going to be equal to 1. So notice, if I'm looking at this, I'm going to say, well, the tangent of 45 degrees, because I put my 45 degree finger down, is going to be the square root over a square root. Okay, so the square root of, we've got 1, 2 digits here, and 1, 2 digits here. So the square root of 2 divided by the square root of 2 is just 1. So you can see how that very easily matches up to our table over here. The tangent of 45 degrees is 1. Now, as you can see what we're going next, we're up 60 degrees, okay? We're looking for radical 3 as our answer. So if we go down and put our 60 degree finger down, so the tangent of 60 degrees, I'm going to write tangent of 60 degrees is equal to the square root over the square root, okay? Now, how many digits do I have up? 1, 2, 3, and then 1 on the bottom here. So I've got radical 3 on the top, radical 1 on the bottom. The square root of 3 is just square root of 3, and the square root of 1 is 1, and then there we go. Look at what you got. And then the last one here is coming up on 90 degrees. Now 90 is undefined. Okay, we have an undefined here, the tangent of 90 degrees. The slope of a vertical line is undefined. So if I scroll down here, whoops, where did it go? Oh, that's where we're right here. Okay, so I've got 90 degrees here right now, right? So I'm looking at what is the square root. I put my 90 degree finger down. Okay, and you're going to see, what am I going to write here? Hold on a second. 90 degree finger. There we go. So I'm going to say the tangent of 90 degrees is equal to the square root of the digits over top of each other. Now I've got 1, 2, 3, 4 digits, and notice there's no digits over here. So the square root of 4 is 2, and the square root of 0 is 0, and then there we go. This is undefined because we have a 0 in the denominator. So the tangent of 90 degrees is undefined. Okay, so I hope this helps. You now should be able to generate this entire table using just your left hand.